Hello and welcome to the Daily Space for today, June 14th, 2019. I am your host for the day, Dr. Pamela Gay, and I am here to put science in your brains. Today, I just want to remind you before we get started that we still have rocks to mark and boulders to measure on the asteroid Bennu. Right now, there's a little tiny spacecraft called OSIRIS-REx that is out there orbiting this little tiny asteroid that's only half a kilometer across. This particular asteroid appears to be boulders all the way down. It is literally an interplanetary rubble pile. Imagine a whole bunch of boulders and gravel in a interplanetary dump truck that just got lost in space and gravitationally gathered together to form an asteroid. That is Bennu. And we want to use OSIRIS-REx to dive down and grab ourselves a soil sample. And we need your help to find the safe place to take our spacecraft down and do that kind of work. So if you have screen space, open a window to bennu.cosmoquest.org and help a mission out. Mark some rocks and measure some boulders. This particular image that I'm showing, this is one of the early versions of the software that we did. And that is the marks of one of our team scientists. That is the kind of mess you can expect to see. So on to today's science. Today, almost 2 years after the Cassini spacecraft plunged into Saturn's atmosphere, we still have new scientific results coming out of this mission. In a June 13th paper, we're presented new details of Saturn's rings that show us that this little moon, this is Daphne shown in this image, this little moon Daphne is capable of, well, raising up waves in the rings of Saturn. And thank you for those bits. We thank all of you the best way we know, which is with cute dogs. So Daphne can be seen here raising really complex waves in the ring that is right next to it. For those of you who don't know, this right here is Daphne. I'm pointing in the wrong window. This right here is Daphne. Now, looking at this image, it's really hard to tell what the angle is that Cassini has on the rings. And it's even harder to figure out what is the alignment of those waves. It kind of looks to me like those waves are extending out into the gap between the rings. They're not. While taking this image, we have the ring structure of Saturn, and it's being looked at what's called a very oblique angle. This shows up better in front of my face. This particular angle makes it really hard to figure out the alignment of those waves, but it was easy for the scientists and their software. And it turns out those waves that we're seeing in this image, these waves, wow, I'm really bad at green screening. These waves up here, they're actually vertical to the rings. So if you have the plane of the rings, they're rising up. And they're driven by the gravity of little Daphne as it orbits. So this is kind of cool. And it's not the only new results that we got in this particular paper. We also have new information on what is the structure of the dust and other material that exists between those tightly put together rings that we're used to seeing. So the top of this image that I'm showing, this is a normal optical color image. And I'm going to point out the image I just showed you. Its color has been stretched a lot just to make the structures easier to see. This is artificial color. This is a black and white, no color image. And the top one is, well, what you would see with your eyeballs if you were totally colorblind and looking at the rings. The bottom image is a subtraction they did to remove those primary structures so that they could see what is the structure between the rings. And what they found out is with some of the rings, those little tiny thin Zen garden style ones on the left, those particular rings, well, they don't have a lot of structure between them. But those bright rings towards the right, that heck, we can see structure just looking at them, they have a bunch of noisy, clumpy material between the rings. And that noisy, clumpy material, it's there, we think, because there is debris that orbits around Saturn that isn't in the same orbit as those rings. So the rings are going around like this, but there's other stuff that's going around like this. And as it goes around at an angle inclined to the rings, it has to punch through periodically. In fact, twice per orbit. And as that debris, crushed up comets and stuff like that, punches through, it creates this structure in the rings. Now, this new science is super cool, and it's probably not the last of the science we're going to see. Cassini, well, it returned 630 gigabytes of data collected over 294 orbits around Saturn. With all that data, we can expect new understanding for many years to come, which is good because we don't have anything planned to go back to Saturn right now. On to a different telescope. This is NASA's Spitzer Space Telescope, and it is yet another example of NASA's ability to eke every possible photon, day, night, life cycle out of the telescopes, space probes, robots, and rovers that it launches. This particular space telescope is one of the many amazing observatories that was constructed in the glory days of the 1990s and early 2000s. And we're really glad it's still working so many years later, because replacement telescopes really aren't in the plans of the moment. This particular great telescope was launched 16 years ago, and it has already launched twice as it not launched. It has already lasted twice as long as anyone has expected. And during its early phase, it sent us back infrared images that you can only get using special liquid-cooled systems that block out the thermal noise of the optics around the instrumentation. Or rather, the instrumentation around the optics. Now, in 2009, Spitzer ran out of coolant, but they had a plan for that. They also have a passive cooling system on board. Some of you may have something like this for your commercial off-the-shelf CCD that you use on a personal telescope. Well, this passive cooling system has allowed them to do warmer infrared astronomy, working at different wavelengths, but still sending us back data that we have no other way of capturing. And over its observational life, Spitzer has revealed a new ring around Saturn. It has studied the evolution of distant galaxies. It has helped us understand the evolution of nearby stars in our own galaxy and nearby galaxies. And it even has turned up planets, including the planets around TRAPPIST-1. Now, while it is still doing amazing science, it has now been announced that Spitzer's going to get turned off for good on January 30th, 2020. Its funding is going to go on to support other NASA endeavors, whether they be science, manned exploration, don't know. And this shutdown is partly driven by Spitzer's growing distance. Spitzer isn't in orbit around the Earth. It's not in orbit in a Lagrange point that we carry with us on our orbit around the sun. In fact, Spitzer is in an Earth-like orbit going around the sun. And Earth-like isn't the same thing as it's in the orbit that Earth is in. And because of the differences in its orbit, it is slowly lagging more and more behind us in its passage around the sun. And this growing distance, well, makes it harder and harder for us to get its data back. And with this growing difficulty, that has built up over the decades of Spitzer's operation, well, all good things must come to an end, and that particular spacecraft is going to get turned off. And this is a sad day, but given the limits on NASA's budget and the demands on what it must accomplish, this is understandable. Understandable and sad. It's hoped that the James Webb Space Telescope is going to be able to give us back our infrared sky when it launches, if it launches in 2021. But until then, Spitzer, you are our only scientific hope. Gather all the photons you can until you get shut off in January 2020. Okay, continuing on. Spitzer and Cassini were just two of the many telescopes that launched during the golden era of NASA's great observatories. The last of the great observatories to launch was the Fermi Gamma Ray Observatory, originally named GLAST. This telescope is 10 years old, and like Spitzer, it's still orbiting and it's still making amazing discoveries. One of the mysteries that Fermi was designed to solve while working in conjunction with the spacecraft Swift is the origins of gamma ray bursts, these bright bursts of gamma ray radiation that had previously been detected. Gamma ray bursts come in two basic flavors, those that are short, lasting generally a few seconds, and those that are long, generally lasting many, many minutes to sometimes a few hours. Over its lifetime, Fermi has been able to measure 2,300 bursts and counting, and has been part of allowing us to understand that these short period bursts come from the merger of compact objects, for instance, the merger of two neutron stars. And these longer period bursts, the long gamma ray bursts, they appear to come from especially high energy supernova when really large stars, well, explode. This week, a new catalog of more than 186 gamma ray bursts was published in the Astrophysical Journal. Contained in this new catalog, a catalog that has 120 authors. Well, this catalog highlights the diversity that gamma ray bursts come in. There are extremes. This catalog includes the half-second duration short gamma ray burst GRB 081102b. It includes the long duration gamma ray burst GRB 16023AS, a gamma ray burst that lasted roughly 10 hours. It also includes the furthest away gamma ray burst that we've been able to measure the distance to, and this is something we've only been able to do a few dozen times. This furthest away gamma ray burst measures in at 12.2 billion light years away. That object is GRB 08916c. That burst also had the energy of 9,000 normal supernovae. So that was one heck of a distant explosion. Now, this is not the first catalog Fermi has put out, and here's to hoping it won't be the last, as Fermi continues to get its mission extended, and as we really don't have plans to build something to replace it. Do you catch a continuing theme today? There's great science coming to us from these great missions that were put together, some of them dreamed of in the 80s, started in the 90s, launched in the early 2000s. And here's to hoping that someday we get back into planning these suites of great observatories as our scientific needs continue to grow and some data continues to be beyond our ability to get here on the surface of the planet, because for good reasons, like it lets us live. The atmosphere blocks, well, gamma rays, and for no good reason other than it can with water vapor. Our atmosphere also blocks a lot of the infrared radiation. So we can only see these things from space. And we are so grateful for the spacecrafts that continue to allow us to make these measurements. And we are here at the Daily Space because of you. And we are also grateful that you continue to support us. And thank you for allowing us to be here. Now I'm going to stick around and answer your questions. And while you type them in, I'm going to remind you to please at CosmoQuestX. And while you type them in, I'm also going to remind you that we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are here thanks to the generous contributions of people like you. The Planetary Science Institute is a 501c3 nonprofit. This means your donations are tax deductible where the law allows. Now, if you can't make a financial contribution, we totally get it. I can't support all the things I want to support. But what you can do is just help spread the word. Help us find more people, including you, to map out the rocks and measure the boulders on Bennu. Help us grow our audience and help us find other streamers to give us a raid. We go live pretty much every Monday through Friday at 1 p.m. Eastern. That is 10 a.m. Pacific, 6 p.m. London time. On Sundays, Annie brings you the Sunday Science Hour. She is currently actually working on reducing Spitzer Space Telescope data to show how we go from the black and white images that come off the telescope to the magnificent color images that you may have in your calendars or as your desktop background. So spread the word and help us spread the science. Okay, I'm going to scroll to the beginning and see what questions you have asked. It's Friday, it's 6 o'clock, and it's CosmoQuest, according to AstroB London. Yes, that is true. And I will remind you, we are also going to be recording a live episode of Astronomy Cast in an hour and 40-ish minutes on our YouTube channel. So today you get extra chances to get extra science. Thank you, Wayne Johnson, for the bits. So Paranor is asking, is Daphne a captured object? Daphne being the tiny moon located in this image. We don't know. It actually looks like it could have been built up through the collision of a variety of particles over time, building something bigger and bigger, and actually, I have the hiccups, and actually kind of ravioli shaped. There are many ravioli shaped icy objects orbiting Saturn. Okay, scrolling. So Mr. Bill Ackman says, I have seen you on TV on the Science Channel. Yeah, I've gotten to do some TV over the years. One of the things you guys may not know is talking heads like me actually get paid nothing when we appear on TV. It's called journalistic integrity, where they don't pay people to say things because it might bias what they say. Yeah, so that's a thing. Thank you for donating so that I can talk science to you here. I promise I have integrity. Okay, Larry Weird is saying, did you see any smoky brown nebula before Spitzer? So this is where I have to admit that I'm young enough that my adult life has been dominated by Spitzer, and all of Spitzer's images have erased everything prior to Spitzer, so I don't remember. I'm sorry. Yeah. Looking. No Hanny today. So Larry is asking, when does Astronomy Cast shut down for the summer? We're going to shut down after 4th of July. I think we're going to have an episode going live the Monday after 4th of July, and that will be the last episode of our season. We're going to record one or more live episodes while we're together for the Astro Tours at Joshua Tree. And you will hear from us next around Dragon Con in September. We will keep the daily space going. We may take the week of 4th of July off. I need to talk with Annie. Okay. That's all of your questions. I'm going to make it rain for the dogs just as a general thank you if anyone is still up here. There, come here. Come here. There's the other one. Go. Because, hey, I can. Thank you, Comic Girl, for hosting us. Thank you so much. So, that's all I've got. Yeah, I am now going to look and see what other streamers are out there today. Our Discord community is a great place to go and talk astronomy, but if you're interested in science and in general, the Knowledge Fellowship is a place where a bunch of educational streamers congregate and share out everything that we're up to. It looks like our friend Oh Bother is currently live, and we are going to raid Oh Bother. So he is a maker. He does a lot of awesome, I'm writing maker instead of bother. He does a lot of awesome tool creation and woodworking and just making stuff, which is something we need more of in this world. So we're going to give him a raid. I'm going to roll the credits, and we will see you on the other side. Wherever you are in the world, remember to have a fabulous morning, evening, afternoon, and if the weather allows, get yourself outside and look up. Yeah, I'll see you all on the other side. Bye-bye.